Hi, let's solve this really common chem problem about the quantization of energy. We're going to do this as fast as we can, so let's go over the two formulas that we need to know for problems like this. One of these formulas is not going to be used in this problem, but let's go ahead and learn both of them first. So the first formula we have is C is equal to wavelength times frequency. So in this formula, C stands for the speed of light, and if you remember what that is, it is going to be 3.0 times 10 to the eighth power. And that is in meters per second is our unit. Sorry about my messy handwriting there. Then we have the wavelength symbol that represents wavelength, like I said, and that is going to be measured in meters most of the time. Let's go ahead and make note of that. And then we have V, which is our frequency. And in this problem, it looks like we are calculating the frequency. So let's go ahead and highlight that. It's important to remember. Um, and yeah, this was our first formula. Now that we've established all the variables, let's go on to the second formula. We have E, oh, let me write in black. E is equal to H times V. So in this formula, we have our first variable E, which is going to represent the energy of a photon. Energy of a photon, and that is also involved in this problem, as we can see, um, that we have a photon having energy, this number. This is our energy of the photon. So, okay, we've established that. Let me highlight this in yellow just so we can correspond those two things. And then we have H, which is Planck's constant. And a constant is any number that is always the same. So in this case, we're just going to get the whatever number that Planck's constant is and plug it into the formula if needed. So Planck's constant, we know from prior knowledge, is 6.626 times 10 to the negative, 10 to the negative 34th, and then our unit is joules times seconds. All right. And then finally, we have V in this formula, which we already know is frequency. So let's go ahead and duplicate. Oh, let's go ahead and duplicate that and just place it there. All right, so we've established what both of our formulas look like and how they work. So let's go ahead and figure out which one we're going to be needing for this problem. So in this problem, we're calculating the frequency. All right, both of these equations have a frequency involved, so that is similar in both of them. But the information we're given is the energy of a photon. So since this equation has nothing to do with that, we're not going to be using it. And since this equation does, we're going to be using this one. So we are solving for V here, but we have the value of E and we have the value of H. So let's go ahead and write out our equation so we can start solving. E is equal to H times V. Now, since we're solving for V, we can make this equation a little bit simpler. Just do some basic algebra and divide Planck's constant on both sides so that we have V is equal to E over H. And now this equation is going to be much easier to solve since we already have our variable isolated. Oh my gosh. Boy, I'm struggling. All right. So since we have our variable isolated, let's go ahead and plug in the numbers. So V is equal to the energy of a photon, which has been given to us at 2.000 times 10 to the negative 12. And energy is always measured in joules. So I'm going to put that symbol there. And then we're dividing by Planck's constant, which we already know as well. We've already written that down. 6.626 times 10 to the negative 34ths joules over seconds. All right, so we can go ahead and cancel out the unit joules here because it's common on both sides. So we're left with seconds on the denominator. So basically our unit for this problem is going to be 1 over s. And if we remember, 1 over s is equal to hertz. So that is going to be our unit for our answer here. All right, so we have our unit established and we also have all of our numbers laid out in front of us. So I'm just going to use my calculator to plug all these numbers in and we're just going to solve. So we get this giant number that goes something like 3.018412315 dot 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 times 10 to the 21st power. But we do need to remember the rule of sig figs, where if we multiply or divide, it's always going to be um, the dividend or divisor with the least sig fig. So in this case, both of them have 4 sig figs. So we're just going to make sure that our quotient also has 4 sig figs. So we're going to do 3.018 times 10 to the negative, sorry, 10 to the 21st power, and then our unit is hertz. And let's go ahead and check if that was the right answer. Yes, all right. So that is how we solve this problem.